Hello everyone. Welcome to the first of the series of videos on this module called Thermofluids. This module is about the two things basically, thermodynamics as well as fluid mechanics. Okay, you learn all that is about fluids and how you can derive your calculations of forces and energies based on the topics that will be laid out in this series of videos. Okay, but very first, right off the bat, let's take a look at the lecture notes that is over here. Okay, if you have the notes, chapter 1 is what we're going to talk about. Is where we're going to kickstart this whole thing, and within a few videos, we will hope that you will obtain these few learning objectives to be able to describe the basic properties of fluids, namely density, viscosity, pressure, be able to calculate shear stresses, be able to explain the relationship between pressures, the different forms of pressures like absolute gauge, atmospheric, static, dynamic, and stagnation pressures. You should also be able to know how to calculate based on different kinds of pressure units. You will also learn how to calculate the buoyancy forces and the hydrostatic pressure values, be able to explain vapor pressures and cavitation and such. You will also be able to read off the pressure reading devices and know how to convert them into gauge pressures. And the last topic is about mass conservation, and you will learn things about steady flows and what exactly is a mass flow rate and volume flow rate, and how using the mass conservation equation to calculate for the flow values for the flow problems. Alright, so the first subtopic is about a fluid. What exactly is a fluid? Okay, there are two kinds of main fluid that we'll be looking at. The first one is gas. Okay, gas, a very direct example is air. Air is a gas. Okay, and liquid is also a fluid. Liquid, we will be looking more into oil, water. Okay, these are just two examples. Of course, there are many other liquids that are existing around the world, but most of the cases will be addressing these two main liquids. All right, and what do these fluids do when they are in static or they are in dynamic configuration, when they are moving flows or where they are stuck in the pressure in a vessel? Okay, they will exhibit different kinds of properties like temperatures and pressures and shear. Okay, and pressure and shear are two key kinds of forces that we'll be looking at for this chapter. Pressure is pressure force, okay, and a shear force. If you look at pressure force and shear force, it is very similar in the terms that it is a force, the unit is Newton. Okay, but however, if you look at pressure itself, pressure is actually a force per unit area, so it is actually Newton per meter square in terms of units. Okay, Newton per meter square is also equals to Pascal. So 1 Newton per meter square is equals to 1 Pascal. Okay, pressure has this unit, and so does shear. Shear is also in Pascal. Okay, the main difference between these two forces are that the direction of action. Okay, if I have a solid surface here and the fluid is above the solid surface, the pressure force from the fluid is actually going to act perpendicular to the surface. Okay, but for shear, right, shear, if the fluid is above and is going this way, the direction of the shear force will be parallel to the surface. Okay, so this is the solid surface here. So pressure, one is acting perpendicular, okay, and shear is acting parallel to the surface. And another word for perpendicular is actually normal. Okay, it is in a normal direction, means perpendicular. And the other one is tangential. Okay, so the tangential direction is the parallel direction to the solid surface. Okay, but both will be in pascals. Okay, so before we talk more about forces, okay, we will need to look at a few other properties. Okay, the first one that we have to highlight is called density. Okay, density is the the mass of the fluid, okay, over the volume of the fluid of which it occupies. So the unit is kilogram for mass and volume is meter cube. This is the SI unit for mass, this is the SI unit for volume. So the SI unit for density will be kilogram per meter cube. So this is related to page 5. Okay, over here. So it describes over here density is rho. Okay, it is Greek letter rho, which is mass m over v, mass over volume. Okay, and there are some examples over here. Density of air is 1.2, about 1.2. Density of water is about 1000. Density of mercury is 13,600 kilogram per meter cube, and density of the oil, typical oil, will be about 800 to 900 as such. Okay, so there are some interesting pointers over here. You can see the density of air is actually about 1000 times less dense than water. Okay, so it's actually really light. And the density of mercury is actually 13.6 times heavier, denser than water. Whereas for oils, for typical oil, you'll get values that is roughly less than 1000. Okay, what does this mean? This one is directly related to what we call the relative density. Okay, relative density. How many times denser is the fluid compared to water? Okay, that is the description, and the formula is seen over here in page 6. Okay, relative density, or another name for it is specific gravity. Actually, they are the same. RD and SG is the same. Relative density is the density of the substance over density of water. So take for example, relative density of mercury. Okay, this is the chemical symbol of mercury, Hg. Okay, the relative density of mercury is the density of mercury over density of water, right? So you know that the density of water is 1000. Density of mercury, as discussed over here, is about 13,600. So you get this, and the answer will be 13.6. So relative density of mercury is 13.6 times of water. So RD is 13.6. Is there any units here? No, because the units for the numerator is kilogram per meter cube. The unit for the denominator is also kilogram per meter cube, and they will cancel out. The units will cancel out, and it will give you a number that has no units. Okay, so RD of water, of course, is 1. Okay, RD of oil is, let's say, about 0.9. Okay, so that's how it works over here. You'll be using this more often as the module goes deeper in. And just to let you know, you will see that the denser materials will have a value, RD value, right, that is more than 1. So if the RD is more than 1, right, that substance is going to sink, okay, in water. If the RD is less than 1, then the substance is going to float, like oil. Okay, so you can see this RD is less than 1, so oil is going to float on water. So that's basically the concept. Alright, so we'll stop here and we'll talk about the other properties in the next video.